All right, so you guys have just completed the do now, which asked you to observe two bonding examples above. What is similar and different between the two examples? Our first example is an ionic bonding. All right, and the second example is a covalent bonding. So what do they have in similar? All right, well, to me, they each have electrons, specifically valence electrons. And then over here in the covalent bonding, these are the valence electrons. What else do they have in common? They are atoms. They both include atoms, bonding of atoms. Okay, how are they different? For the ionic bonding, sodium is completely transferring or giving up its valence electron to chlorine. So for the ionic bonding, it's a complete transfer of valence electrons. And for the covalent bonding, hydrogen and oxygen, they are sharing those valence electrons. Okay, let's move on. Today, I think we're going to make one big video instead of many, okay? All right, so let's move on to the notes. So review, electronegativity is the element's ability to attract an electron to itself. Okay. Covalent bonding, just a quick review, is done to fulfill the octet rule. Fulfill the octet rule by sharing electrons. Okay? And the new bit of this is that the electrons can be shared equally or unequally. So we can share them equally or unequally. And we're going to dive into that equal sharing and that unequal sharing on the next slide. All right, let's move on. Okay, so we can have an equal sharing of electrons and an unequal sharing of electrons for covalent bonding. The equal sharing makes something called a non-polar covalent bond. So we're just going to say a non-polar bond. Okay. And my unequal sharing of electrons makes something called a polar bond. Okay. So to draw a non-polar bond, we have two atoms. All right. And inside we've got our protons. Okay, that's the inside, those are the nuclei. And then this shows you the, like, almost the size of the electronegativity, okay? So each atom wants to attract an electron almost the same, okay? They're both sharing electrons equally. So they both want electrons equally, okay? A polar bond looks like this. We have one atom that really, really, really wants electrons, and another atom that doesn't, and it's smaller, okay? So over here, both want electrons. Over here, this guy wants the electrons. This guy doesn't. Okay? And what happens is that makes something called a partial charge. Okay? So this side is the negative side. And this side, you see that little plus? This side is the positive side. Okay? So it makes a partial charge. Okay? So we've got our positive side, which is that atom, and our negative side, which is that atom. Okay? So the atom that wants electrons is negative because it's going to take those electrons. The atom that doesn't want electrons is positive because it's going to be kind of sharing its electrons a little bit more aggressively than the negative one, okay? So it's an unequal sharing. The negative is kind of taking a little bit more, and the positive is kind of giving a little bit more. We're still not transferring, but it's an unequal sharing, okay? We can also solve for these using electronegativity values. So for my equal sharing, the electronegativity values have to have a difference of 0.5. So what that means is if you have like a carbon bonded to a hydrogen, carbon's electronegativity value is 2.5 and hydrogen is 2.1. 2.5 minus 2.1 is 0.4. So it's not polar. So to be nonpolar, you must have a difference of 0.5 or below. For my polar friends, let's say I have nitrogen bonded to hydrogen. Nitrogen's electronegativity value is 3.0 and hydrogen is 2.1. That has a difference of 0.9, which means it's polar. And to be polar, you have to have a difference of 0.5 or higher. Okay, and it's electronegativity values for both. Okay, and you can find those values on like a periodic table, or you can go online and type like electronegativity values, or I will give you the values. Typically what I'm going to do is I'm going to give you something that looks like this, and these little red numbers, these are the electronegativity values. Okay, so I'll either give you a list or a periodic table that has the values. So then all you have to do is just find your two elements and subtract your values and see what you get, okay? This is not in your notes, but I thought I'd quickly put it in the slide so you could have an idea of what I would give you or what you would be needed to do, okay? All right, let's move on to the next slide. So today we're also going to learn about bond strength. So we just learned about polarity. It's pretty short. It's a really short snippet. Now I'm going to ask you to kind of switch hats and learn about bond strengths. So bond strengths is the, like, how strong are things actually bonded together, all right? Okay, so for ionic bonding, the bigger the charge, the stronger the bond. Okay, the bigger the charge, the stronger the bond. So let's go look at what that means. So we have, let me see, do I put a table in here? Yes, I do. Okay, so let's say that our compound is sodium bonded to chlorine. Na takes a +1 charge. Cl takes a -1 charge. Because the number is 1, it's not a very large charge, so this is a weak bond. Okay, now let's look at calcium bonded to chlorine. Calcium takes a +2 charge, chlorine takes a -1. Since we have that +2 there, we're becoming a little bit stronger. But we still have that -1, which is keeping us from being even stronger than that. All right, now let's look at Mg, magnesium bonded to oxygen. Magnesium takes a +2 charge, oxygen takes a -2 charge. Since we have 2 and 2, we're at a stronger. So I would say this was actually the calcium bonded to chlorine, it's a strong bond. Magnesium bonded to oxygen is a stronger bond because of that +2. And then lastly, if we look at another one, let's have aluminum bonded to oxygen. Aluminum takes a +3 charge, oxygen takes a -2. Since we have that +3 and that +2, this is the strongest. All right, so as those numbers increase, so as the charges increase, the strength increases. Okay, so that's for ionic bonding. So this is for ionic bonding. Now, we're going to learn about covalent bonding. So for covalent bonding, it's not about charge, it's about something called a single bond, a double bond, or a triple bond. So a single bond is when you have one bond between your two elements. Okay? A double bond is when you have two bonds between your elements. And a triple bond is when you have 3 bonds between your elements. Okay? The single bond is strong. The double bond is stronger than the single bond. And the triple bond is the strongest. Okay. And then typically, covalent bonds tend to be stronger than ionic bonds because both elements are equally interacting, where ionic bonds, they're connected by a charge. Okay? All right, that concludes our videos for today. It's about a 15-minute video. When I'm done talking, will be about 16 minutes. I know I didn't split it up today, but that's because I'm using a new system. Let me know how you liked this video compared to the other ones. All right? Thank you for watching. Make sure that you listen and you take your notes. And now go do the practice. All right? Ask me if you have any questions. Thanks.